Good. Okay. So this is a talk I've been wanting to do for a while. The evolution of a lot of the newer games are pushing towards better measures against this, so it's kind of more relevant now. At the end of the video, I will show kind of a proof of concept that I created realistically probably about 7 years ago. I stated 7 on the main page that you guys would see. To start off, never underestimate the people of the information security community. So I basically just, for the fun of it, I'm like, hey, if I get 500 tweets, I'll wear a male romper to the presentation of CircleCityCon. And so it went from pretty much 100 to like 600 in a few seconds. So the thing about a male romper, it was more of a meme. It's not really much of a thing. So the closest thing I could get to it is this. I mean, by definition, it's a onesie with shorts and t-shirt. This has a hoodie, so it's considered a jumpsuit, but you know, it'll do. So about me, I'm a security engineer at a payment processing company during the day, sometimes at night. I'm officially never been a network engineer. Obviously messed with routers and switches many times at the job. Never been a video game designer or engineer, but everything I show in the proof of concept will explain itself. So start off in the audience, who plays video games? Right, who plays video games online? Right, who plays first-person shooters online? All right, so we got a good amount. And who does play on Xbox Live? Oh man, burn. All right, so common misnomers. Every time I hear this on somebody's like, oh man, he's lag switching or he's doing that, the first thing that comes to my mind is some like 400-pound kid in their basement with a physical light switch connected to their monitor, flipping it up and down, and he's like, oh, I'm gonna get them. You know, it's not how it works. Pretty much to summarize, how you get lag is the internet's really complicated. You know, it's nothing more than that. This misnomer, I think, started from a guy that created a YouTube video as kind of a prank. The same type of prank is like, hey, throw your iPhone in the microwave and it'll recharge it type of thing. And it became kind of a thing where everyone assumed that existed. And he literally took the upload link, which I'm not sure if you can see that well in there, but the green one, which is the upload, he wrapped it around a physical light switch, and he said you hit that and the connection will lag. Pretty much will break it, and this won't work even on gigabit, so it's just a common misnomer. So another misnomer that kind of annoys me a bit is people refer to everything as ping, not latency. Essentially, ping is a utility for ICMP echo request and echo reply, which gives you a round robin of that, giving you the definition of what your latency is. But when you're referring to, your speed or, round robin speed of the connection, that's latency, not ping. Ping is a utility. It's the same exact thing as saying, instead of how fast is your car, you say how Ford is your car or how Toyota your car is. That doesn't make sense, but that's the same exact thing as when you say how's your ping. No, it's how's your latency. So that's pretty much, one of the things, my pet peeves when people always refer to it. The other problem with that is that a lot of games actually put that in there, showing like your ping is, 300 milliseconds because they're using a utility, but you should refer to it as latency. So to explain latency, how that works in general, and this is using the most realistic approach, basically using fiber optics plus wave propagation. So speed of light times 1.3. And using this calculation, it'll basically show you how long it will take to go from New York to Sydney, or in my case, Atlanta to Tokyo. And it's quite amazing when you think about it, if that's even that fast. Like you can communicate to somebody in 1/10 of a second all the way on the other side of the world. But it's not really how it works. That's doing just the math of that. But every time you basically send a piece of information out to a destination farther away, you're going to go through a bunch of hops. They may be Ethernet. There may be multiple co-locations. They're going to have some type of integrated circuit that's recalculating how to send that data packet. The location you might be going to might have a lot more bandwidth being hit on it, and it may slow it down even more. So this is actually what realistically you get from Atlanta to Tokyo. So mathematically, you should get 110 milliseconds. Realistically, you get about 211 milliseconds, but still quite amazing when you think about it as the internet as a whole, because you're essentially going from one side of the world to the other side, and you're only, again, 1/20th of or 1/10 of a second you're getting there. And explain the concepts of different types of speed and cables. And this is one of the things that I kind of like when you do research on a paper. You kind of go through a bunch of things and you find some really weird things that you would never look at until you actually force yourself to do it. And one of the things I found out is that, my whole life I've viewed as fiber being, quote unquote, like faster in the sense of latency. And it's technically incorrect. And I'll explain it real quick so that it kind of makes sense to you guys. So ignoring the medium, so the actual modulation is on the end, just 100 meters of fiber optics. When you send a photon through there, which is going to be massless, does not have any friction, like Ethernet would have, electron going through there creating friction. It's basically not riding a rail like Ethernet. Ethernet goes one straight line. A photon in a fiber optic cable is like a little hole there. It's basically that photon's bouncing back and forth in there. So you got wave propagation. So you times it by 1.3. Everything travels at the speed of light. The difference is that fiber optics bounces around instead of riding a rail down there. Is this realistic? Not really, because Ethernet has a certain length due to the fact that it's it's electron. It has mass, creates friction, energy, slows down. You have 100 meters at max with it. Fiber optics, you could get in kilometers with it. So in video games, wow, that's a really small font. That sucks. So in video games, you have older ones that represent latency. You'll have like the bar system, and this just breaks down the bars of it. So 4 bars is 100 milliseconds, which is great, good connection. 3 is mediocre, 100 to 200 milliseconds. 2 bars, 200 to 300 milliseconds. 1 bar is 300, which is pretty much unbearable. Granted, some newer games require better latency because they're higher frame rates. They're designed a lot better. They use actual dedicated servers geographically. So on most modern games, over 100 milliseconds is kind of bad now. But this is like older, like Half-Life games, Modern Warfare, stuff like that. So I want to go over what they use in video games, the TCP versus UDP. This is an image from a previous slide. UDP is essentially the honey badger of networking protocols because it really doesn't give a crap. So TCP in games are used by things that require reliability. So if you need something that has, data that's sent and can never be tampered with in the sense of like it drops or anything like that, that's what it's going to be used on TCP. It's not something that's going to be used for real time. So like in a game, if you get a kill, you send that over TCP because we want to make sure that data is correct. So you have your correct KD ratio. Pre-game lobbies to determine who's going to be connecting to what game, what host is going to happen. They do a TCP session for that. Player list choices, and even if like you get an achievement on a game, both PlayStation and Xbox Live, you get an achievement that is sent to their coordinating servers through TCP. UDP is pretty much used for anything in a first-person shooter. And this goes over the actual design of the game engine and how it communicates. So to take into account how to make it real time, but at the same time, not have that issue of, it may not be as reliable, but it still has a way to check it and validate it. So UDP in this, you basically, every client, and this works both for client host based and dedicated servers, but every client that communicates sends up to a dummy state. The dummy state basically gets, where my mappings are in the map. So I may be a player trying to shoot this other guy, I hit the trigger, all that data is sent over to a dummy state. The server itself is designed to basically take in those dummy states and correct it, say, hey, you're trailing too far off, or we didn't get these types of packets in there, therefore we're going to go ahead and correct that somehow. But everything is basically monitored that way, and you're able to use UDP through those methods to basically create a reliable data because the server itself is creating like a checksum of all that. This graph did not scale well, apparently. But this is just an overall view of this going over ITech, all their game engines from like the original Quake all the way down to the latest one on that one is Rage. But you can see that a lot of games will base their engines off of this. And the reason why I pull that graph up, this previous mapping, this is actually pulled from the Quake 3 game engine. So any type of modern game like Half-Life 2, Portal, Modern Warfare, Titanfall, anything that's using like a id-Tech engine, Source engine, anything like that is based off the same exact design. And even other games like Halo, Battlefield, they take in the same exact concept because id-Tech laid the foundation way back in the day. So one of the things that you'll notice in video games is that when you're playing, you get this kind of jerk motion because you're trying to go somewhere and it's pulling you back. The reason why it's doing that is going back to that whole UDP stateful session. You're trying to tell the server, hey, I moved up forward. It may have missed that packet. It may have also realized that that server was not processing that information at that time. So the master state kicks in and then relays it back saying, okay, you're moving back here. So that's why you get that quote unquote rubber banding effect. That's once you understand how a game engine works, that it makes a lot more sense. And then there's a newer method starting back in the day with Modern Warfare 3 that a lot of newer games do. It's called lag or input compensation. So instead of everyone having their correct latency, it kind of pads it. So I may have 50 milliseconds to the server, and another person does 100 milliseconds to the server. It will pad one of the people's connections to 75 to create a more of a level playing ground. And that's something that there was a huge controversy, big issues about that at that time about that. But it makes sense if you think about it. The other thing is it also makes sense why, like, you're playing a game and you shoot somebody and you're like, dude, I completely ran around the corner. How did he shoot me? It's because of two combinations. They might have padded the connection a little bit so that the bullets actually countered towards it at that time. The other thing is that he may have better connection to the host at that time, so he was physically viewing that behind the wall, or prior to running to that behind the wall. So you got the two different types of servers that are out there. Peer-to-peer, or also known as client-host. A lot of like Call of Duty games will use this, and it basically just means that when you start up a game, one of the consoles or one of the PCs will become the dedicated host at that time. They basically pick what's the best connection. The benefits of it is it for the developers, it's costly. You don't have to maintain servers. Everyone that has a console is now their own server. Geographically, any like larger, newer launched games, you're going to have a lot of people playing it, so therefore you could always find somebody always closer to you. And maintenance, you don't have to. You just update the game. You don't update the actual server. And then you could create some interesting designs, such as lockstep networking. Bungie basically created that for like your player versus environment games. The benefits of the actual dedicated servers, which I want to mention, I have links at the end of here where I got some of this information, like that UDP design. The game engine was on a thread I found. There's going to be some references from John Shiring's video on Respawn Entertainment. If anybody doesn't know what Respawn Entertainment is, it's a company that basically came out from Infinity Ward when Activision, the publisher, screwed them over, and you could see a lot of those people move over to it, and you can see the creative development of that, and some of that stuff from their video I was able to create this research off of. But dedicated servers, you could actually produce updates on the actual server. So the biggest problem as a game developer is that when you actually create a game and the content of it, you have to go through a bunch of processes. You have to go through your internal QA team, and then you go through the actual publisher's QA team. And then at that point, you go through a QA team of the content delivery network. You may be doing an update on Xbox Live. You may be doing an update on Sony PlayStation Network. They have to verify all that stuff. And then there's basically a 1-week wait process for all that. So if you find like a bug in the game, somebody's exploiting a map, you could basically go ahead and patch that through dedicated servers on the back end without having to go through the content delivery network, which saves it goes from like a week to you could probably do it in 24 hours, depending on your internal team on the QA process. The other thing with the dedicated servers, you're going to have a proper connection. You're going to have good upload. The biggest problem with peer-to-peer is that everyone has some type of asynchronous connection. So your home ISP is going to be 75 megs up and 75 megs down and 5 megs up. If you have DSL, good luck getting more than a megabyte going up. And that's one of the biggest drawbacks, because you can't have larger lobbies in those type of environments because you're capping out the threshold of your upload. The other thing is that, those clients that are communicating are on somebody's home network. If, your roommate opens up Netflix, you just kill the server's connection because you're streaming data through there. And then the other thing that the benefit of dedicated servers, you can render local data, so you could actually update and improve data without having to go through the actual clients. You prevent network manipulation. Spoiler alert, I will be talking about this. And then you will also not have host migration issues. So if you're playing on a client-host situation, somebody turns off their Xbox or their power goes out in the area, that host will die. You don't get that on dedicated servers because they're in a co-location. They have UPS, redundant power. They have, many things in there that prevent that from ever happening. So going into the cloud, a lot of the newer games, Titanfall, Halo 5, Battlefield, are actually utilizing the cloud computing to benefit off of this. And props again to John Shiring's video, which I will reference at the end. He talks about the game design in Titanfall. So you could create like smaller instances, like a small instance for the search lobby. So you initially join that. A medium instance for the stat engine, and the stat engine will update geographically inside their own data center. A larger instance for the game server engine, so that you have a bunch of people communicating to one, larger cluster or, AWS instance. Well, I think they use Azure for their cloud-based. And then you can also set up regions. The benefit of cloud computing, instead of back in the day having multiple dedicated servers, is that the cost goes down dramatically. The problem is, initial game night, you're going to launch it, you're going to have millions of players play it, and they're going to get bored of it. So in a few months, you just basically pull the cloud computing out of there, and you save a lot of money. And I know a lot of people are going to probably get frustrated at me because I'm talking about good things about cloud computing in an information security conference, but there's nothing really, like, when you think of cloud computing, it's like in a financial market, that's horrible because it's personal information on there, and you're sharing a same resource on there. If this is games, there's nothing private on a game server. So there is benefits to that. And I know it's somebody else's computer, but that's, to a developer on a shoestring budget to release games like this, it makes sense. There's also other cool things for like load balancing on a server. You could pull a server off of a cluster. So if the West Coast starts getting hammered because some script kiddie decides to DDoS the game because he didn't like it, and you could just pull that out of the cluster. So when you do the next game search, that game is not, or that West Coast server that's getting hammered is not there anymore. And the other thing, as I mentioned before, maintenance and patching. You have the availability to do DevOps on this and update the games super fast without having to worry about a lot of things like that. Privacy. So want to iterate, your IP address does not equal your home address. That's one thing I see a lot of people be like on video games. You have a 12-year-old squeaker. He's like, I got your IP address. I know where you live. I'm like, no, you don't. Essentially, you have to get a subpoena to find out where that IP address correlates to that ISP. You're going to know geographically where they live. I live in Atlanta. If you look up my IP address, it'll show that I'm in Atlanta, but it won't tell you, anywhere, remotely close where I am. You could also use a VPN service to hide your IP. Party chat will actually show your IP address. So if you're in a game and you jump into a party chat, and they're designed to be peer-to-peer, that will actually, if you look in your router, you could actually view the IP addresses communicating, connecting. The more you talk, you can see that bandwidth go up. But if you're in a client-host game, the only people that know the people's IP address is the host. If you're communicating to a client-host, you're never going to see anybody's IP address. You're just going to only see the host itself. On a dedicated server, that goes all away. You know the server you communicate with, but you don't know anybody else's IP address that's in that game lobby at that time. So what can they do if somebody finds your IP address? Well, they could DDoS you offline so that you can't play that game anymore. If you have like Xbox Live and you have a port open for port forward your 3074, they could just hammer that connection. PlayStation Network has their own ports. You could also find geographically where they live and call out some BS on that. Technically, if you have that IP address and they have like weak services publicly exposed on it, and maybe an Internet of Things device, or their router firmware is outdated, you can technically hack that and get in their network. So yes, but as of finding physically where somebody lives, it's nearly impossible. I'm sure there's some methods out there, but it's not much of a thing. So I'm going to go over the proof of concept that I created. Again, I created this about 7 years ago. I did it once as a trial just to see if it even works. It blows my mind that I have not seen a single video on YouTube about it. If anybody finds a video on YouTube about it, hit me on Twitter. This is something that was super easy. When a lot of people do talks here, they talk about proof of concepts. They're like, they reverse engineered a piece of code for a while. They fuzzed it, did all this stuff. Really cool things. This is super simple. Once you learn about it, it's like, wow, that's really easy. But prior to me talking more about it, I just want to make sure, because this is the way the game engine works. The peer-to-peer and client-host games are always going to be affected by this just because it's a design flaw. There's nothing you can do to patch it or fix it. So prior to doing that, I just want to make sure people repeat this. I'm here for educational reasons. Nobody? Come on. Thank you. I will not use this proof of concept for selfish reasons. I feel like I'm at church. Pen tester is not liable for presenter is not liable for my stupidity. Thank you. All right, cool. That was easy. I lied. I'm actually going to talk more about technical information before I go over it. So who's ever watching online, they're going to be like, oh, son of, But anyways, starting off with quality of service. Who all knows about quality of service? Good amount? Yeah. It's simple. Just sharing a piece of the pie. It's an IEEE standard, 802.1q, and also AD. So it's basically a 32-bit piece of data that's shoved between the MAC address and the Ethernet type. So in here you can see the two 802Q ones. The one in the middle is the 802Q. The one below is actually AD. AD basically takes and incorporate with the VLAN tagging. So it has two packets, so you could actually specify what virtual network it's going to be on. And then all this is relevant. I'll talk about why in a few. NetFlow. So for this proof of concept, you're really, and I'm actually using this image for another presentation or training in a couple weeks, but you're only going to want to know your total length of the actual data packet and the destination port. But you could basically, every piece of information that goes over your router, you could track that and create QoS tables off of it and validate it. This proof of concept is going to be using I'm using the Tomato firmware, but you could really use any router that's out there that has QoS. I like Tomato firmware because it's way easier to use. The scaling and graphing on it is really nice. I did a talk about a couple of years ago. I had B-Sides Huntsville about the different types of aftermarket firmware, but you could do this on OpenWRT. You could do this on ASUS default router firmware, things like that. Again, I'm just using Tomato because it's way easier to use. If you're somebody that wants to be malicious that's joining in late into this video online and you want to do that, you just go to that website right there. It says lemonparty.org/about me, and that goes to your backdoor of the router. So Tomato firmware has CSATs and RStats. It's a really interesting way that they basically store data locally and let the web browser offload all that power. So it uses AJAX, which is asynchronous JavaScript and XML. All this stuff is basically a C program that creates like a counter stating, this data is coming in. It's going to create more information on that. And then it gets to the point where your web browser initiates a session. It creates an SVG graph inside your web browser. So it's great. It doesn't take much power on your router, and you're able to create really good graphs at real time off of it. So in there you have your QoS tables. This is basically shown in here. move my mouse over there if I can. You can see in here 3074, that's my Xbox. That's basically a port going out publicly. That's going to the Xbox Microsoft server. There's another one in here for DNS from the Microsoft server, but you could view connections. So if you have a friend that's playing this game and you're talking to them on party chat, you could actually just sort by bytes in or bytes out, and you could view that bandwidth go up, and you could click on it and see geographically, okay, my friend from Ohio, is that his IP address? Click on it and you see that it's the only Ohio address communicating to your router right now. You know who he is, and then therefore you could add that to a whitelist, which this whitelist will be used for that proof of concept I'll talk about in a second. So how do you get host? Get good connection. Ensure port forwarding is enabled. Keep playing games. Eventually, host will drop in a client-host situation and you'll gain host. But don't be stupid. Don't break the Computer Fraud and Abuse Act and try DDoSing somebody online. I do not condone to that. It's really stupid. There's no benefit of doing that. In certain games, there's, and this is just 2 games I mentioned, there's many other games that you could determine how you get host, or how, if you currently have host. In Call of Duty, your name will show up first when you connect to a lobby, and everyone else's name will be below you. The other thing is if you hit the back button, the menu will show yours is full green bar connecting, everyone else will be red bar coming in. And that will basically prove that you're a host. If you join a game and you see people's names above you that are connecting, you're not host. In Halo Reach, there's some interesting things like game physics that happen. When you're a host, if you punch a dead body, it has a ragdoll effect. If you're not host, you won't see that. Next round game will load differently. So if you're playing a game that has multiple rounds in that game, the next round will, if you're not host, will just show like 1 minute, 23 seconds because that's the last round how it ends. And if you're host, it'll actually show the full counter time prior to loading the next round. There's game modes that people create in a Halo Reach, basically in Forge, which is basically just a map creator, that you could actually spawn in a vehicle inside a cube, and inside that cube, you're going to be basically spawning in first if you're host. Therefore, you get more points in that cube, and it's just an easy way to determine it. And then I saw a forum online states that your color stays the same at the beginning of the game. So there's game modes that have multiple people in there that have different colors, and you view the correct colors of everyone loading at that time, you have host. So in here, you're going to basically whitelist a bunch of IP addresses in your QoS tables. You're going to, and this is best used if you don't have a roommate. My roommate went out of town and I recreated this. But more people in your connection, the more it's going to be harder to mess with or tamper with and create this kind of QoS method to nerf their connections. But you want to whitelist all of your game console connections. So Xbox will have a DNS server that's internal to the console. You basically nerf that connection, you're going to cause more issues. There's going to be, you just want to get a baseline. When you just turn it on, you see what's all happening. Your goal is to basically nerf other people's connections that communicate to you in the lobby. So you could just whitelist everything at that time. And then once you do that, you need to set the bandwidth. Can you guys see that at all? The numbers or anything like that? Okay. It's weird from this angle. But realistically, when you set QoS, you kind of put in the proper number of your upload and download speed, and then you kind of put a percentage of each item. And there you can see that there's going to be a whitelist nerf connection that I modified in there. But you're going to set it to a threshold that's more realistic for the game, so that you give everyone in that game basically 56K dial-up speeds. So you kind of take in, like, you're going to be playing like a 4v4 lobby or an 8v8 lobby. You take that, do the math of that, you do a percentage of like a 1% or 2% of that, and then you basically state, hey, these people that are going to be playing in Xbox Live and communicating, they're going to get that amount of bandwidth. And then when you're basically playing the actual game itself, you have this rule in here called, nerf, or I just labeled Xbox Live ports. But you want to, on Tomato Firmware, you could set a threshold from 0 to 2 megs. I highly recommend doing that, because if you don't, once you start nerfing the connection, everyone that joins in the game is going to instantly get nerfed. they're probably going to drop their connection before they even join the lobby, because there's a lot more bandwidth that happens at the initial connection. So everyone that communicates will get a good amount of bandwidth, and then they'll hit that 2 meg threshold, and they'll go back down to 56K dial-up speeds. And you could either just enable QoS at that time, or just take that item and move it up, and basically overwrite the whitelist rules. And that basically, you get this from it. So in here, you can see the connections, and they all go red bar. And then I have 2 people I whitelisted in there. One, I want to thank my buddy Dave. I posted on Facebook, I'm like, hey, I'm going to play this really old game. Does anybody have it? And he's like, yeah, my little kid has it. I'm like, sweet, I'm going to play it with your son, that you don't mind. And he basically, we did that. He was one of the very bottom one, and then the actual top one that you can see full green bar the whole time. That's another person that met. He sent me a message saying like, that's a really awesome gamer tag, and I'm like, cool. I'll go ahead and add you to this so you can see what happens. And for the record, if Microsoft listens to this or something like that, just ban the terminology "fut bucking." I don't know who would ever create a gamer tag like that, but they banned multiples in the past, but they never blocked them. So I created this gamer tag specifically for this proof of concept because I didn't want my gamer tag exposed to this. But it's just for the laws, I decided to create "fut bucking lag because you're going to read it wrong. But that's pretty much the proof of concept. I mean, you're essentially creating a QoS graph to set everyone's speed to like a piece of the pie that's 56K like a 56K modem that nerfs their connection to the point where they're still connected to the lobby, but they can't do crap at all. And then you can whitelist people that you're friends with so they could do whatever they want. It's a horrible concept. I only done it like twice before, and that was like 7 years ago. And when I first did it, I'm like, wow, this actually works. Like, this is super simple. And I went around like knifing people, and they're just like running into a wall. They can't do anything. I'm like, God, this sucks. I feel so bad. I will never do this again. And then, 7 years later, I had to recreate this proof of concept for you guys. Yeah, it's simple, straightforward, and it only works on peer-to-peer games. So your newer games like Titanfall, Halo 5, Battlefield that are all on the cloud, this does not affect it because you're not ever going to be host. And you have to be host to do this. If you do this while you're not host in a client-host situation, your connection just goes crap, but it really doesn't affect anybody else. In the future, I am hoping that more and more games will push towards cloud-based computing because you could offload bigger game lobbies. You could do a lot better stuff that I mentioned in the past about that. But in the future, there might be other methods to allow peer-to-peer communication. And I'm literally just throwing out buzzwords. I have no idea what I'm talking about in here. But basically, tokenized blockchaining. So instead of, I like how he's laughing about that. Now, basically, if you have a central authority and you basically communicate to each other, to the peers, to basically validate information and kind of update those chains of information, and then you don't really have to do blockchain. You could just do a server that communicates and stores stats, and if somebody has known bad stats for connections over time, you could pretty much never make him host because he's going to be more malicious. And I'm pretty sure, not the tokenized blockchaining, but pretty sure Bungie's done things in the past because they're one of the few games like playing like Halo 3 and Halo Reach. They're one of the few games that I've seen that actually did pretty well with given the person that actually had good connection host. And I'm pretty sure they stored stats. But most games, I don't think they store any type of connection stats. So if you drop or you're constantly creating issues, they don't care. But this doesn't even prevent it. This is more of a a measure to counter it. But if you're doing this type of method I was showing you, you can't really stop it in that sense, other than moving to the cloud. So I want to talk about a little story that I did 7 years ago, playing Modern Warfare 2 back in the day, and this is before I worked in information security. I was probably working like help desk support at that time. And this guy with his gamer tag had a Kush and a bunch of X's in there, complete gangster wannabe type of guy. I was playing with. He basically started talking in the lobby about how he's a elite hacker and all this other stuff. And I wasn't much in that community at that time, and I was kind of curious. So I kept asking him questions. I'm like, so how do you hack people? How do you do this? And he's just feeding me these kind of generic answers. And I kind of keep providing him more and more information. He tells me that you have to get this specialized tool that's under the dark underground. And he says, like, what tool is that? He says, Cain and Enable, not Cain Able, but Cain and Enable. And I'm like, what's that? And I'm Googling at that time trying to find out Cain and Enable. And apparently I found a website, Cain and Able, which is an old like Windows back, prior to Kali or Backtrack tool for penetration testing. It's still kind of relevant for like ARP spoofing because how easy it is to use. But, I found that tool, and he's talking about how you have to go to these underground websites and you're probably going to get viruses, and it's just publicly on there. And I asked him, like, so if you get viruses, what antivirus do you use? And right there, I knew this guy had no idea what he was talking about. He was like, the best in the world, McAfee. I'm like, okay, all right. So this guy has no idea what he's talking about. So I keep humoring myself, asking him more and more questions about, like, how do you, like, get somebody's IP address? How do you, once you have them, what do you do? It's like, oh, you can find all this information. You can find where they live. He talked about how if you invite somebody to party chat, you could find their IP address, which was correct. One of the few things he was correct about. But the more and more I asked the questions, the more I noticed he was kind of hesitant of providing that information. And because he was with this bunch of his, gangster wannabe friends in the lobby, and he didn't want to be called out on that because he didn't really know what he was talking about. So out of nowhere, he's pretty much like, I asked him another question, and he's like, you need to stop asking so many questions. You don't want me to show up at your front door with a shotgun. I'm like, whoa, internet badass here. So when that happened, I'm like, this guy's not going to know where I live. He's not going to figure that information out. I know that at least enough about the internet. So I kept asking him more and more questions. While I did that, the first thing I did is pull up his gamer tag and put it on a Google search, and just to see what I could pull from him, because this guy threatened to shoot me with a shotgun. I want to see who he is. And lo and behold, I type his gamer tag, which is a bunch of X's and Kush in there and a bunch of other stuff, and it came up with a MySpace profile. And his MySpace profile is public, so I got his first name, his last name, where he lives, and a few other pieces of information. And the most ironic thing about it all, in his MySpace profile, he had like a picture on his left arm, like a tattoo of a gun. So definitely his persona. He also had like these like glitter gifs of marijuana on there that you would see, like something you would see at like Joann Fabric, that like type of glitter thing on there. And I'm like, oh, this guy has a complete tool. So I kept asking him more and more questions, and knowing that he's going to get more frustrated about it. And then he kind of barks back at me, and I'm like, all right, Cody. And then he's kind of pauses. He's like, how do you know my name? Are you friends with me or somebody I know? But apparently on his Xbox profile, he has his first name, but not his last name. So I'm like, Cody, I know your first name, I know your last name, I know where you live, and you just threatened to shoot me with a shotgun and all this other stuff. And I'm just, playing the bluff game. I don't know where he lives. I just know he lives in Columbus at that time. Which was also kind of funny because at that time I was living in Akron, Ohio, which is a 2-hour drive. But he basically starts, kind of backtracking a little bit, but kind of trying to pride like how I know this information. He thinks I'm one of his friends. And then at the end of the game, I basically tell him, hey, Cody, and his last name, you just make sure you don't threaten other people. And then he just jumps off the game because he knew that I knew his last name. And I also told him, like, I know that you have Time Warner Internet, which everyone in Columbus does. So that was just an easy guess. I pretty much told him that, and he kind of like really started freaking out. So for like an hour after that, he kept sending me messages like, who are you? Who do you work for? Are you the FBI? Do you work for Microsoft? And I'm like, wow, this guy really just caught my bluff. I'm like, he didn't realize that I could just Google his gamer tag. I'm like, oh, whatever. So I'm messing with this guy more and more. Oh, that GIF did not render properly. Anyways, I mess with him more and more, and to the point where, he threatens a lawyer on me, and he doesn't want to talk to me anymore. And the next day comes by, and my buddy Chris comes over, and I'm talking to him about this. I'm like, yeah, I just completely trolled the crap out of this guy, and he has no idea why I know all this information. All I did was Google his gamer tag, and he's like, dude, you need to mess with him some more. So I'm like, I don't know. I think he already learned his lesson. He threatened to hack me. He also threatened to come over and shoot me, but now he kind of backed off. I'm like, we should let it be. He's like, come on, mess with him some more. So I open up his account, the message on there, and see if he was online, and he's offline. I'm like, I can't mess with him anymore. I'm like, I'm not going to do that. I'm like, and then I look into his friends list, and lo and behold, there was another gamer tag with Kush and a bunch of X's on it that was playing Modern Warfare 2 in a private lobby that was open to the public, so I could join it. So I'm like, is that his alternative gamer tag? I'm like, should I mess with him? So I jump into that private lobby. And you could hear him talk to his friends, and then instantly goes quiet. Because he knows me. He knows who I am. And when that happens, I'm like, hey, Cody. And you could just hear that voice in him. Like, when you're driving on the road, and you see a deer, you're not like, oh crap. You're like, your adrenaline pumps. You're like, oh crap. You're really freaking out. And you can hear that in his voice. Like, he has no idea how I just joined his lobby. And I told him, like, hey, Cody, I know you threatened a lawyer on me and a bunch of other stuff, but, if you're going to take me to court, don't do it next weekend. I'm taking my mom to Red Lobster for her birthday dinner. And it was just, my buddy was back there cracking up. And I'm like, just, do that. And, don't, please do it at like a month in advance. And he says, like, just backs off. He's like, whatever beef we had in the past, let's just drop it. I don't want to deal with this anymore. And I said, okay, I called him an effing doob, and then I left the lobby, and I felt great. I'm like, this kid's never going to threaten to hack somebody, never threaten to, like, shoot somebody again. He learned his lesson type of thing. So that's the story about Cody. And a little bit of, OSINT is what you guys call it nowadays, but this is pretty much Googling his gamer tag and priding him in, information enough where he felt like I knew what I was talking about. So the video for John Shiring, it's about an hour and a half long. It's from Rackspace. He works at Respawn Entertainment, who made Titanfall, and he talks about all the game mechanics and the engines of the cloud platform that he designed, and the stat engines and all this other cool stuff. Mousy, there's like an older post on a forum I found somewhere. I don't even know what this is. But some of those images that I got for like the UDP sessions, input compensation, that's where I got all that information from. So if it wasn't for those two people, I wouldn't be able to present that type of information, because those are the only sources I found that actually had relevant things like that. Toastman for Tomato firmware. The firmware I used was Shibby, which is a variant of Tomato. But Toastman did a really great write-up on all the functionality of QoS. So if you want to learn a little bit more about that, it's links on there. And I'll post all these links out. You don't have to write them down. Plus, it'll be recorded, but I'll post them all on Twitter so you guys can reference it. Destiny had Bungie had a great write-up on the Destiny design and some of the previous designs in the Halo games. 5 minutes? Okay, cool. Follow me on Twitter. If you have any questions, shoot me, a question about it. I'll also post all those links on Twitter so you can reference that if you want to do your own research. And again, like I said, simple, QoS manipulation, but you basically nerf people's connections to dial speed. So open the floor to some questions. I got 5 minutes. So anybody has any questions? Okay. They all look like deer in headlights right now. All right. Well, have a good night.